Let's take a look at what happens when we are simplifying radicals that are not perfect squares or perfect cubes. Well, one thing we have to think about is there a perfect cube or a perfect square inside the radical that we could factor out, and then we could reduce it that way? In other words, we know that the square root of 20 could factor into 4 times 5. And 4 is a perfect square. We were looking for factors of 20 that were perfect squares. Well, that's going to be the same as saying the square root of 4 times the square root of 5. And now I can simplify the square root of 4. It's 2. What's left is 2 times the square root of 5. That's a simplified version of that radical. Let's take 50. Do you know of a perfect square that is a factor of 50? You probably thought of 25. So 25 times 2 are the factors of 50. We're going to pull the 25, the square root of 25 out, multiply it times the square root of 2. And now when we take the square root of 25, we have 5. It's still multiplied by the radical we have left, which is the square root of 2. So the square root of 50 simplifies to 5 times the square root of 2. What about example 3? It's negative a square root of 33. Now, the negative doesn't have anything to do with our square root because it's simply sitting out front. But can you think of any factors of 33 that are perfect squares? Really, the only factors of 33 are 11 and 3, so there are none. So this one is already simplified. It's already in its simplest form. Let's look at example 9. We have 9 times the square root of 36. Well, 9 times the square root of 36 we can resolve. It is 6. We would say 9 times 6 is then 54, and that's simplified completely. What about variables? In example 5, we have the square root of x to the 7th. Now, we know that we would divide exponents by the index, or the 2, in order to get the root of it, but 7 is not divisible by 2, but what 6 is. We could say x to the power of 6 times x, and we know that gives us the x to the power of 7. We can then take the radical of x to the power of 6. Let's move it out and say x to the power of 6. The square root of that would be 6 divided by 2, which would be x to the power of 3 times what's left under the radical, the square root of x. For number 6, what can we resolve in this radical? Well, we can resolve the square root of 36. We can say the square root of 36, and we can multiply that times. What about the square root of a squared times a? Now, there's something else we can, when we resolve the square root of 36, we have 6, and we can just think, okay, I can resolve the square root of a squared is really a. What's left under the radical? Just my a. Notice I'm shortcutting my steps so that you don't have to write as much. So that resolves down to 6a times the square root of a. Number 7 is a little harder because we don't normally see the square root that's inside the number 96. And I'm going to tell you what it is. It's really the number 16. 16 times 6 is 96. And then x to the 4th is a perfect square, isn't it? So let's see, where are the perfect squares that we can resolve? Well, we can say the square root of 16. We can say the square root of x to the 4th. And then we're going to have to leave under the radical the square root of 6. Let's resolve these. 16, square root of 16 is 4. The square root of x to the 4th is x squared. And we just have to multiply that times the square root of 6. Example 81. Once again, we can take the square root of 81. We know it's 9. So we've got the square root of 81. We're going to multiply that times, let's think of square roots that are inside b to the 5th. We need even numbers, so b to the 4th times the square root of b. We can resolve the first two. Square root of 81 is 9. Square root of b to the 4th, divide by 2, it's b squared. We cannot resolve the square root of b. So we just have to multiply those times the square root of b. Now let's talk about cubes. Once again, cubes, number multiplied 3 times to get a number. Now we know the cubes. You know the first 5, and you should have learned them. And 8 is one of those. And 8 is a factor of 24. So when we're talking the cube root, we could think 8 times 3. Well, I could say the cube root of 8 could be factored out separately times the cube root of 3. Cube root of 8 is 2. Times the cube root of 3, it does not simplify anymore. So the cube root of 24 simplifies to 2 times the cube root of 3. Another example, the cube root in example 10 is the cube root of 81m squared. Well, 81 has a factor that's a perfect cube. We can factor 81 into 27 times 3. And then we still have to have m squared. It's not a perfect cube, and there are no perfect cubes inside it. So what can we simplify? Well, we can simplify the cube root of 27. We're going to be multiplying that times the cube root of 3m squared. That can't come out from under the radical. So we say the cube root of 27 is 3, and we leave the rest of it, 3m squared, inside the house, the radical house.